the National Security Agency, which is usually if they're putting out an advisory for everyone about cybersecurity stuff, you know that like something big is happening. They are talking about SCADA. So, and ICS. So industrial control systems and supervisory control and data acquisition systems, that's SCADA, I memorized it,
Nice.
are systems that are designed to control heavy machinery, industrial backbone stuff, manufacturing, basically the kind of things that are controlling big, expensive, heavy, often machines that are very, very expensive. And these are the kinds of things that generate power. They do all sorts of critical roles in our society, and they are controlled by a kind of limited degree of different computers that are specifically designed for monitoring and controlling these sorts of products. Now, the problem with that is because there's kind of a limited amount of ways you can do this, and there's a limited amount of manufacturers that produce products for the specific market, these are vulnerable to some sorts of attacks, especially because the general public doesn't interact with SCADA devices very often. So a lot of security researchers really don't focus on SCADA. And as a result, I would say it might be a little bit behind in some other areas that get a lot of attention and are kept kind of up to date by finding the worst vulnerabilities and getting them patched quickly. SCADA is kind of a dark area in hacking because a lot of people don't, just don't interact with these devices. Like how often do you, go by a system that's controlling a jet engine or a giant turbine or generating electricity for an entire city? Obviously, the consequences of messing that up are much higher. So often people aren't allowed to test out and work with these sorts of systems, either because they're very expensive or because they're just not really available for public use. So that means these sorts of systems are vulnerable, especially when they're connected to the internet. And that is exactly what a lot of these things need to have done in order to work with a giant system of other machines doing something else. So in order for these companies that are scaling up and up to keep an eye on all their assets, they frequently network them and expose them to the internet. And that is where the potential for cyber attacks that impact things like power generation, electricity, just all sorts of bad things could come about if hackers are able to break into these systems and cause substantial damage. Now, Alex, do you remember the Stuxnet attack?
Yeah, I know vaguely of what happened there, but there was like some conflict, U.S. Israeli, and I think like we developed like some sort of
No. Nobody ever officially claimed responsibility. Some unknown party which never asserted responsibility created.
I see. Okay, but glossing over that and talking about, I guess, the technical details. They had infrastructure propped up that was controlling stuff like centrifuges that were like spinning uranium and like some other stuff that I don't exactly understand. But malware was developed that got control of these systems and like screwed up various industrial processes and like spun their chemicals the wrong way and like screwed up various stuff they're trying to monitor.
Yes. So basically they were able to, an unknown party was able to infect an industrial control system that was spinning very, very specialized and very expensive uranium centrifuges that were trying to make potentially weapons grade nuclear stuff. And what was able to happen is the centrifuges spun so quickly they destroyed themselves and set the program back really far. And that is kind of the classic example of industrial controller SCADA hacking. But nowadays, because everything is connected to the internet, it is much easier than it used to be. And the problem is also that these SCADA devices now have something called, what was the name of the pipe something?
It was Pipedream.
An actual toolkit specifically targeting them that is being used by a state-backed actor to try to aggressively gain control and break into these systems. So now that there's, instead of just a bunch of random different tools that might be used against it, an actually super flexible and very, very capable tool chain to go in, attack, gain persistence, gain privileges, and then eventually potentially destroy these systems. That threat being out there is a huge wake-up call for all these connected systems and all of us who rely on them. So this is kind of a scary and almost kind of chilling note to have out there, that these sorts of industrial control devices are now being targeted with a lot more advanced weaponry, I would say, than they have been before. So anybody who's managing SCADA, anybody who's managing industrial control systems, this is definitely a wake-up call that some of these are vulnerable, and there does need to be a certain layering of protection in order to make sure if there's some sort of unusual access, you're able to detect it and shut it down super quickly. Because a lot of these things are so expensive that if a threat actor was able to gain rapid penetration into your network, network, begin to destroy things and cause irreparable damage, there's really not that much time to react to this sort of intrusion because the consequences are so severe. So yeah, we're not talking about ransomware here. We're actually talking about like destroying computers, destroying equipment, being able to cause fires, being able to cause damage. And when you're talking about things that are, I'm thinking of that Die Hard movie where they like reverse the gas flow and cause like, like that, basically that movie, it was kind of going off of like the worst example of what could happen.
It's definitely within the realm, though, of possibility here.
Yeah. So maybe not everything that happened in that Bruce Willis movie, but some of the things were basically based off of what could happen if industrial hacking became a heavy target of like an actual assault against a country. So not very nice to hear. And definitely a little anxiety-provoking considering we all rely on these sorts of things, and they frankly have not gotten the kind of attention that a lot of other systems have just based on their nature and the fact that they're not very available to the public.
It's scary, but also interesting. And what I thought was particularly weird is, God, I forget who discovered it, but apparently the Pipedream software kit or whatever that's being used to exploit like these SCADA or ICS systems was like discovered before it was actually before anyone was actually able to weaponize it or like use it to attack anything. And there's like not a lot of details out there about like how it was discovered, who discovered it, but it's like tied to a somewhat anonymous advanced persistent threat group that's currently being tagged as the Chernovite Activity Group.
Oh, over on your screen.
Oh, yeah. Yeah, so I just thought that was interesting that it was like discovered before it was actually found being used in the wild. But yeah, of course this is scary and has like a lot of pretty bad implications for what can happen. Because also like there's just like a small amount of like companies that have like an oligopoly over like ICS and like SCADA, like Schneider Electric and some other various companies. And there's also like a small amount of, or rather just like a standardized set of like protocols and stuff like that that's being used to control like various like PLCs, which are like the computers that are used within ICS systems. But basically this toolkit just provides like a lot of automation that's able to be applied over different like ubiquitous protocols and stuff like that that's able to control these SCADA systems just because they're like found everywhere and like super common and implemented.
Yeah, the standardization is kind of the problem here because I'm thinking of like tools like Routersploit or Metasploit, which have presets based on known configurations that are out there that are vulnerable and make it really easy for anybody to run a pen test, provided you can learn how to use this toolkit. The thought that you could go from needing to be like specifically a SCADA expert in order to go in and do some damage to just using something like Metasploit to basically discover all the SCADA devices on a network, be able to like get root on them and then do whatever bad thing you want to, or whatever the equivalent of root is on a programmable logic controller. That is a very real problem now that this toolkit is out there, and somebody who doesn't have as much skill could potentially use it to automate a lot of the things that used to be difficult or would weed out a lot of threat actors from being able to pull off these sorts of attacks.
Yeah. It's also kind of dumb, but I saw like one way to like mitigate this. Someone suggested using like industrial IoT or like IoT devices instead of SCADA. So I said it's like outdated and archaic. But I think that honestly just like opens up a lot more attack vectors.
Yeah, no, IoT devices.
Because there's like a lot more research into like IoT than there is SCADA, even though like to be honest, like some of it is kind of archaic.
Yeah, that's a very funny take. It's a very funny take. But yeah, so I mean, so much of the United States still relies on SCADA devices in order to just keep things running. It's really important that people realize that this is a huge and underserved area of cybersecurity. So if you're just going into cybersecurity and this sort of stuff fascinates you, trust me, there's lots of need for SCADA hackers because there's lots of systems out there that really would make a lot of problems happen if they were to go down.